Water by Xander Tooze, Liam Murphy, and Alex Housden. History. The history of water starts with the Greek Empire, when they established water as one of their four elements, alongside earth, air, and fire. Now, that was around 600 BCE. Significantly later, Henry Cavendish discovered around 1760 CE that water was in fact not an element, but a compound. He found its composition in 1781 CE. He found this composition to be H2O, or 2 hydrogen, 1 oxygen, also known as dihydrogen monoxide. Johann Ritter in 1800 CE confirmed this with electrolysis. 87 years later, Svante Arrhenius found the ionization of water in 1887 CE.
The atoms that make up a water molecule are hydrogen and oxygen, specifically being 2 hydrogens for every 1 oxygen. Water is bonded covalently. This is because, unlike ionic bonds, where electrons are either gained or lost in order to reach an equilibrium, they are shared between the hydrogen and oxygen atoms, with each hydrogen sharing a single electron with the oxygen, allowing the two of them both to reach an equilibrium. Water is also bonded together through a hydrogen bond. This is because hydrogen is involved in the molecule, and hydrogen is a partially positive atom and is attracted to oxygen being a partially negative atom. And finally, water is polar, which means it has an electric charge. This is because, again, oxygen has a slightly negative charge, and hydrogen has a slightly positive charge. And since like atoms have the same charge, both of the hydrogen atoms present are positively charged. This causes them to repulse, or to spread out in order to get as far away from one another as possible. This causes the hydrogen atoms to undergo a slight compression, which leaves them at a 104-degree angle, making them have a bent shape.
Water's chemical structure did not become evident until the late 18th century, since it had first to wait for the discovery of component elements, hydrogen discovered by Henry Cavendish in 1766 and oxygen discovered by Joseph Priestley in 1774. These molecules come together by using hydrogen bonds. This means one of the hydrogen atoms is shared between the two molecules, and having one oxygen molecule to form H2O, or better known as water. The shape of a normal snowflake resembles a hexagonal shape, which is used to represent the structure of the water molecules. The unique properties of water consist of ice floating on top of water, as a coated film, or in other cases for small animals to be able to walk on water. Having a high and low heat capacity allows the boiling point at 100 degrees Celsius and the freezing point at 0 degrees Celsius. Another unique fact about water is that it has an attraction to itself. The reason being that water is a polar molecule, which water is attracted to each other, thus making water stick together. Soap can stop the cohesion of water sticking together. This all occurs because the atoms, bonds, and geometries create polar molecules to add surface tension, allowing the ice to float. The reason for the low density of ice results from its structure. At low temperatures, the water molecules align themselves using intermolecular hydrogen bonds to form an open hexagonal structure. This structure has many gaps and spaces, and is therefore less dense than the corresponding liquid structure. The hexagonal structure is also responsible for the sixfold symmetry of snowflakes.
Here are 3 ways that water is important. 1. Every human is composed of water. The average adult body is about 60% water. But that's not all, which leads us into number 2, which is that water is essential for human survival. Water is so important because we can only survive for 3 days without it, and eat lower-level consumers and producers in the food chain that also need water to survive. Lastly, number 3, economies of ocean nations rely on fishing. Nations like Japan and Korea eat so many fish, shrimp, and seaweed that it is ingrained into their culture and daily lives. They even made video games out of seafood. Fishing is also a major export for these regions, meaning that without water, and therefore the ocean, and therefore fish at all, these nations would struggle with finances and not be as powerful as they are today.
New and surprising facts. Here are 5 facts that our group found interesting. Number 1, water was once an element. As mentioned, water was an element along air, earth, and fire in the times of the ancient Greeks. And this is what's shown in the image in the top right corner of the slide. Number 2 is that ice floats in water, and that's very rare because usually the solid form of a substance does not float in its liquid form, but water is actually at its densest in its liquid form, meaning that the ice will float because it is less dense. Number 3, water forms in hexagonal patterns when it forms with hydrogen bonds, which is why ice is hexagonal in nature. Number 4, water's composition was discovered before electrolysis. We found this interesting because now it seems like we would have to rely completely on electrolysis, and it was just completely mind-boggling that they were able to do it without electrolysis being around. And number 5 is that water is the universal solvent. This means that water can dissolve almost every substance into it. Of course, there are some exceptions, like oil and water don't mix at all. But for the most part, it is the substance that dissolves the most things. Citations. Here are citations. We use sources like London South Bank University, New York University, and Khan Academy, alongside other sources. Thank you for watching our presentation, and have a great rest of your day.